What is Doppler's effect? Anyone? Change in frequency. Apparent. That means it appears. If you measure, there is no change. But to the observer, it appears. Example is, if there is an observer and train is moving towards the observer, an observer, by closing the eye and getting a change in frequency, can inform you whether the train is approaching the observer or moving away. There is an apparent, it appears. So if you measure, there is no change, but it appears, apparent change. To an observer, it appears. If a train is approaching the observer, frequency increases. The train is receding away, moving away, frequency decreases. So there is an apparent change. The first part is, what is Doppler effect? Yes, apparent change in frequency of what? Sound. Due to what? Due to relative motion of source and listener, observer, receiver, you may call anything. Reason. There is a source, say a train. So there is a vessel, horn, source of sound, you may call it whatever you call. And there is an observer, listener. So number of waves are being generated by the source. If both are at rest, if a source and observer both are rest, suppose as an example, frequency generated is 100 hertz. So number of waves received by the observer is also 100. But suppose the observer starts moving towards, then observer will pick more waves. Why? Because it is moving towards. If it is at rest, it will pick 100 waves in 1 second. If it is moving at certain speed, say 10 meter per second, and every wavelength is 1 meter, so it will pick up 10 extra waves. If it picks 10 extra waves in 1 second, apparent frequency is 110 hertz. So if the observer moves towards the source, it's equivalent a rod in water. Oscillate this rod in water, you generate waves, ripples. If there is a boat, source is at rest, boat is also at rest. So it generates certain number of ripples, say 100 ripples per second. Boat will also receive same number of ripples. What? If a boat starts moving towards the source, it will receive more ripples, more waves per second. That means if it starts moving towards, if the frequency under normal conditions is 100 hertz, frequency, if the boat starts moving, boat motion is towards the observer, f dash frequency will be what? More than 100 hertz. And the other case, if the boat starts moving away, it will pick up less number of. If the boat is moving towards, in this case, boat motion is away. Boat moves away, then the apparent frequency will be what? Less than 100 hertz. Similarly, for source also. If the source moves towards, apparent frequency will be more than natural frequency. If source moves away, then apparent frequency will be less than natural frequency or true frequency. Time with you is 4 minutes to write it. 4 minutes to write. What is Doppler's effect? 4 minutes to write. There are 8 cases. All the cases apparent frequency is equal to what? Yes, observer in the numerator and source in denominator. F is the natural frequency. What is V? V is speed of sound. V is speed of a observer velocity. This is the velocity of a source. All the cases deal with whether we have to mark a sign plus minus plus minus. All the questions cases deal with only this part. You have to mark only the sign. Notes band kar do. Case number 1. Both observer and source are at rest. Both observer and source at rest. Means what? Observer speed is what? 0. Source speed is what? 0. So, F apparent is equal to V. V. Observer speed is what? 0. Source speed is also 0. These signs are immaterial. Whether you mark plus or minus makes no difference. That is why we need not think about whether it is plus or minus. So, the answer is F apparent. This is V, this is also V. This is cancelled. What you get is F. That means what? What you get is the true frequency. Source diagram. Source is at rest, creating a frequency of 100 Hz. Observer at rest, 100 Hz. So, apparent frequency is equal to the true or natural frequency of source. 2 minutes to write. Case number 2. Source moving towards observer at rest. Source moving towards observer at rest. Means what? Source speed is not 0. Observer speed is 0. Source is moving. The diagram is source is moving speed and observer is at a rest. This is the diagram. What do you say? Frequency will come out to be, apparent frequency will come out to be more or less? More. So, concept. From concept you are saying F apparent should be more than F. Let us try. F apparent is equal to observer. Yes, observer speed is what? 0. That means we need not worry about this sign, whether it is plus or minus. Source. Yes, sign should be what? If I mark it plus any value, 300, suppose this is 300, this is 30. 300 divided by 300, if I mark plus, so it is 300 divided by 330. The factor comes out to be less than 1. But we want to make it what? More than 1. Sign has to be negative. That is why minus. Now, suppose this is 300, 330, 300 divided by 270. This factor comes out to be more than 1. The issue in competition is how to mark the sign. That is the only challenge. 2 minutes to write. Case number 3. Source moving away. I will draw the diagram and you will write the expression. Source, train is moving away from observer at rest. This is the diagram. Vs is not equal to 0, you can see this is not equal to 0, it is moving away. Observer is at rest. Try. First you have to write whether it is greater than or less than. Second you have to write it is plus or minus. 2 minutes with you. 2 minutes. If it starts moving away, the number of waves received by the boat will decrease. That is why frequency, yes, what do you say, frequency decreases. F apparent is less than this. What about this one? Now you want to make this factor less than 1. 300, suppose this is 300, this is 30. You want to make this factor less than 1. So this is 300 plus, this is 300, 330. 300 divided by 330. This factor is less than 1. So the sign is plus. This is your case number 3. Case number 4. Observer moving towards the source at rest. Case number is 3 or 4? 4. Observer moving towards source at rest. Source is at rest. Train is at rest. And observer is moving, yes, towards. In this case, source, boat. If boat starts moving towards, it will receive more number of waves or less number of waves? More number of waves. So frequency will increase. So F dash or F apparent will come out to what? More. First of all, source speed is 0, observer speed is not 0. F apparent will be what? More than frequency. Observer speed is not 0. Observer. Source speed is 0. What about the sign now? You want to make this factor more than 1. This is 300, this is 30, this is 300. So sign is what? Plus. 300 plus 30, 330 divided by 300, this factor is greater than 1. So F apparent is more than F. 2 minutes to write. Case number 5 is what? Source at rest. Source at rest. Observer moving away. Source is at rest. Observer is moving away. Formula for the same is apparent frequency is equal to observer in numerator, source in denominator, and you have to decide this sign. Vs is equal to what? Source speed is what? 0. Observer, this is 0, that is why there is no significance of this sign. You can place plus or minus, whatever it is. What about this one? Yes, source at rest. Observer is moving away. Will receive less number of waves. So, this parameter has to be less than 1. In order to make this parameter less than 1, what you place is a negative sign. So F apparent is equal to V minus V observer times this. 2 minutes to write. Case number 6. Case number 6 deals with what? Case number 6 deals with both source and observer moving away from each other. The diagram is both these values are non-zero. Now it is equivalent to, it is combination of two cases. One, you can make source at rest and observer is moving away when you have to decide the sign with the observer. Second, you can take this observer to be at rest and move the source away to decide sign with the source. So it is a combination of two cases. You can refer to the notes and come out with an answer. This is case number what? Yes, source at rest, train at rest, observer moving away. Yes, it is case number 5. Case number 5 and first one is case number 3, case number 5. Case number 5. Second one is case number 3. So when you have to mark the sign with the observer, assume the source to be at rest. Observer is moving, case number 5, observer is moving away, frequency will come out to be less, this factor will come out to what? Less than 1. That means what? Minus sign. Second part, in this case observer is at rest. Forget about this part. Observer is at rest, source is moving away. So you need not to worry about this part. Think of only V, V and Vs. It is moving away. Frequency will come out to what? Less than 1. So for this particular part, you want to make this part less than 1. If you want to make this part less than 1, this sign has to be plus. Denominator value has to be more than the numerator. So it is what? Combination of case number 5 and case number 3. 2 minutes with you to write. Correction is required in the notes. Case number 7. Both source and observer are moving towards each other. Again, the diagram is source and observer are moving towards each other. So, first part, in order to decide about the sign with the observer, observer is moving towards and assume the source to be at rest. Second part, in order to take into account effect of source movement, source is moving towards observer at rest. These are yes. Source at rest, observer moving towards. 4. This one, source moving towards observer at rest. Case number? Now we have to take into account the effect of number 1. If you assume source at rest, means you are not to take into account this effect. You have to decide the sign with the V observer. It is moving towards. If it is moving towards, frequency will come out to be more. That is why this parameter will come out to what? More than 1. If you want to make this parameter more than 1, numerator value has to be more than denominator value. So we need to mark a plus sign. Second part, where you have to decide the sign with Vs. If you have to decide sign with Vs, then assume observer is at rest and source is moving towards. What is the effect? Yes, frequency has to be more. This parameter, this parameter has to be greater than 1. How? This value is V, this is V. What would the sign here? Minus. 2 minutes with you to write. It is a combination of case number 2 and case number 4. Case number 8. All these cases discussed so far, the two particles are moving along a straight line. Along the line joining the centers of the two. But now you have a case number 8, where there is a railway track. On this railway track, there is a train moving with speed Vs. And there is a road. Suppose there is a queue here, number of persons are waiting, number of vehicles, cars, and there is an observer at rest. Observer at rest. So we have to analyze this part. What is the value of the apparent frequency? Formula for this is apparent frequency is equal to observer in numerator value is 0. In the denominator, the value is, say this velocity is what? Vs. This angle, let it be theta. Then component of velocity along this line is this component, Vs cos theta. So that is why this value comes out to be Vs cos theta. What about the sign now? Distance between after some time, this train is in this position. That means what? Distance between the two is decreasing. So this F apparent has to be more than F. This factor has to be greater than 1. So sign here is minus. Now we discuss various possibilities that this train can be at position A. It can be here at position B. Train can be at position C. So we'll discuss 3 possible cases, that is case 8A you can say. When it is at this position, as an example, this is a case when theta lies between 0 to 90 degree. It can be equal to 0 also. Equal to 90 will mean case B. For this case, F apparent is equal to what? F apparent is equal to, we can quote as an example. Example is theta is equal to say 60 degree. F apparent is equal to what? V minus 0, V minus Vs cos 60 is what? 1 by 2. This value is positive. So this value comes out to what? F apparent will come out to what? F apparent comes out to be more than natural frequency of the train. This is one case. 8B. This one. Join the two. Angle between the two comes out to what? 90 degree. For this case, theta is equal to what? 90 degree. F apparent is equal to V, observer speed is 0, V minus Vs cos 90. Cos 90 is how much? Yes, cos 90 is 0. This part is 0, V by V is 1. So, apparent frequency is equal to actual frequency. That means throughout this part, this observer will get frequency more than the natural frequency. The moment train is at this position, the moment train is at the crossing, the observer gets its natural frequency. Third case, last. C. When the vehicle is at C, this angle theta, say 120 degree. Theta lies between 90 to 180. It can be equal to this also. F apparent is equal to V minus Vs. As an example, say it is cos 120. Cos 120 is what? Plus or minus? Minus. After school to college. Second quadrant. Cos 120 is minus 1 by 2. This minus 1 by 2 and this minus, it is plus. So, this factor is V plus Vs by 2. This total factor is less. That is why apparent frequency is less than actual frequency. Means what? If the natural frequency or actual frequency of the engine whistle is 100, here you get more, 110, 109, 108, 107, 106. At this point you get 100. And after that, you get 99, 98, 97. The value is less. So, as theta changes, the frequency will also change. Time with you is 3 minutes to write. Numerical number 34, page 10 by 136. Numerical number 34 is an engine moving with a velocity 36 km per hour blows a whistle which is heard by a motorist driving with 18 km per hour to be 500 cycles per second. That means hertz. Calculate the actual frequency when A part, two are moving in opposite direction and approaching each other. B part, two are moving in opposite direction and receding away. C part, two are moving in the same direction but motorist is behind the engine. D, two are moving in the same direction but motorist is in front of the engine. Velocity of sound is given 330. What is given is, in this numerical given is speed of sound. Yes. Yes. 330 meter per second. Speed of observer. Yes. Observer is a motorist. 18 km per hour. Means what? 18 km per hour. Given is 18 km per hour. We change it to meter per second. Why? SI units. Speed of the source, train. Yes? Yes, 36 km per hour. That means 10 meter per second. Frequency heard, apparent frequency. Given. How much? 500 hertz. In all the four cases, you have to find out what? F. So, this is what is given. Solution for all the four parts. First part, yes. Draw the diagram for the first part. First part is two are moving in opposite direction and approaching each other. Moving in opposite direction. If one is moving along the x-axis, the other is moving in the negative, and the two are approaching each other. Means what? Source is moving towards, observer is also moving towards. Case number, yes. A part refer to the notes. Formula, yes. Observer, source. Case number is 7. If it is case number 7, the sign is yes. Both are increasing the frequency. So this is plus, this is minus. What is given as F apparent? Yes. How much? This value 500. V 330. Observer speed 5. V 330. Source speed, yes, 10. Find F. Solution for A part, when two are moving in opposite direction, F is equal to what? Find value of F. It will come out to be less than 500. Yes, comes out to be 4, approximately 477. Agreed? Approximately 477 hertz. Actual frequency is, yes, 477. They are approaching each other, that is why the apparent frequency is more, that is 500. B part, draw diagram for B part. B part is two are moving in opposite directions and receding away. Observer and source are moving in opposite direction and are moving away from each other also. This diagram is workable. B part, two are moving in opposite direction. What about these directions? Yes, one is moving along x-axis, the other along minus. Receding away means the distance between the two is increasing. Distance between the two is increasing. So the formula is F apparent is equal to observer source. Mark the sign. Effect of each is what? To decrease. So this parameter, yes, negative. What about this one? Plus. Case number. Refer to case number is 6. So F apparent is 500 is equal to 330 minus observer speed is 5, source speed is 10. Find F. F is equal to what? 523. Try C part. are moving in same direction, but motor stays behind the engine. Source, suppose, is moving along x-axis, train is moving, and the motorcyclist, in this case, an observer, is also moving in the same direction. Now you need to think, F apparent is equal to what? Observer non-zero, source non-zero. Now try the sign. See how many of you understand Doppler's effect. This is the question the one which will check your abilities, logic, reasoning, because it is not any of the 8 cases. So come out of the logic. Make one at rest. Suppose the source is at rest. That means you are not to talk about this. Observer is moving towards. It will lead what? Increase in frequency or decrease? Increase in frequency. If observer is moving towards the source at rest, it will increase frequency. So this parameter has to be more than 1. So the sign is what? Plus. In the numerator, this is plus sign. In order to account for the source sign, yes, make the observer at rest and source is moving away. It will result in what? Decrease in frequency. So if you are not to take into account this part, this factor is decreasing the frequency. This factor has to be less than 1. So plus. Combination of, yes, combination of 2 cases. 1, observer at rest, source moving away. Check. Case number is what? Yes, observer at rest, source moving away. Case number 3. And source at rest, observer moving towards. 4. Check these signs. 3 and 4, both the cases, it is positive. 3 and 4, yes, case number 3 and 4, yes. For this part, the answer is F apparent is what? Yes, 500. Speed of sound 300. Observer speed is 5. Source speed is 10. Find F. F is equal to what? Yes, 507. Approximately 507. Try D part at your own, please. D part. Both are moving in the same direction. Source, train is moving towards right. Motorcyclist, observer is ahead of the train. 1 minute with you to write this formula with the sign. 3. Previous part, yes, this was not 300, this was 330. Previous part, this is not 300, this is 330. So you can make correction in the previous part, it is 330. Source, assume source to be at rest. Observer is moving away, will lead what? Decrease in frequency. So suppose source is at rest, observer is moving away, and it causes a decrease in frequency. If it causes a decrease in frequency, this factor has to be less than 1. How? When the sign is minus. Second part, observer is at rest. You have to decide this source sign. Source is moving towards. It will result in what? Increase in frequency. If you are not to take into account this part, this factor causes increase, this factor to be more than 1. How? Negative. It is a combination of case number. Yes. Source is moving towards observer at rest. Yes. 2 and 5. Case number 2. Please check. Case number 2 and 5. Check the sign in 2 and 5. 2 and 5. Case number 2. Yes, it is. It is not marked here. It has to be plus. No, it is not case number 2. Source is moving towards observer at rest. We do it again. Just a minute. Just a minute. We do it again. If there is a confusion, observer is at rest. That means you have to decide this sign. If observer is at rest, source is moving towards, it will result in what? Increase in frequency. Agreed or not? This is case number, check. Case number 2, source moving towards observer at rest. 2. Second part, let source is at rest and observer is moving away. Source at rest, observer moving away, it will also result in decrease in frequency, negative sign. Case number 5. Fine. Fine. I thought I'm doing something wrong. Find F. 492. Frequency is approximately 492.